Problem number 59, a student drops a ball from the top of a tall building. It takes the ball 2.8 seconds to reach the ground. What was the ball's speed right before hitting the ground, and what was the height of the building? Okay, so this is a two-part question. Again, we're going to solve this one just like we do any of the other questions. We're going to draw a picture, list what we know, write down what they're looking for, and then try to find an equation that'll help us use what we know to get the unknown. So, for problem number 59, we have a building. All right. And we're going to make the assumption that the person dropping the ball is just kind of like laying on the building, and they're just going to drop the ball from exactly the top of the building. So, two questions. Well, first let's list what we know, and then we'll address what we don't know. The only thing that we really know is that this is accelerating at 9.8 meters per second. Okay. So now we have to determine if falling down is negative or if it is positive. Well, for our questions on free fall, what your textbook did is they took all the kinematic equations that had acceleration in them and changed the acceleration to g. So we need to think about what that means. And I'll talk about that in a second. Notice, and I'll just write one example down. Oh, we do know one other thing. The initial velocity is 0 meters per second because the ball's not moving at all. They just drop it. They just let go of the ball. So we know two things. But the question that they're asking us is how tall is the building and how much time did it take to hit the ground? Or what was the final velocity? Well, let me read this thing again, make sure that I'm not forgetting anything. Oh, they did give us a time. It also said that it took 2.8 seconds for it to hit the ground. All right, good. So we've got some information. So anyways, here's the thing. If I look at the Freefall equations, which are actually on page 58, they have an equation that's listed as V equals V naught minus G times T. Okay? So the original equation that comes from is V equals V naught plus A times T. So this is the thing that I want to explain to you guys. If you follow the book religiously, it says that G is always going to be a positive 9.8 meters per second. However, Mr. Adams is going to say that usually in the y direction, if we think of like the XY plane, right? Usually going up is down and going up is positive and coming down is negative. And so we agree that the acceleration is going down. Now, if I use this equation, it's been rewritten to automatically orientate going down. The gravity part, the acceleration due to gravity, is always going to be negative. They've changed the equation. Now if I use this equation, Mr. Adams has to remember to plug in the negative value. And that all comes from how I orientate this problem when I draw my picture. Either way, both of these will work. The first question was how fast will it be going? What is its final velocity? So right here, the initial velocity is 0 meters per second. And right as the ball gets here, we want to know what the final velocity is. Okay, so if I do it this way, I get the final velocity is equal to 0 minus 9.8 meters per second squared, okay, times the time, which is 2.8 seconds, okay. By the way, that would be the exact same thing if I were to plug all these numbers into this equation. I get the same thing, the negative 9.8 and stuff. So when I multiply that out, I get V is equal to, let's plug that in the calculator, turn it on, 9.8 times 2.8, and so I get 27.44. This would be meters per second, right? Because one of these seconds will cancel with the second. Meters per second. Okay, so that's the final velocity. It is about 27 meters per second. Okay, cool. That's part A. Part B says, how tall is the building? So now for the height of the building, we're going to need a delta something, right? Delta x, or if we use the kinematic equations, we're going to need delta y. So on page 58, there's a couple delta y's we could use. I could use, oh wait, this is negative though. That's a negative velocity, right? Mr. Adams almost forgot. It's a negative velocity because we're going down. Does that make sense? I'm going to rewrite this because you can't see the negative sign very good. The final velocity is equal to negative 27.44 meters per second. Okay? So, delta y. I don't know. Any one of these equations would work that has the delta y in it. There's one equation I could say y is equal to y naught plus the initial velocity times time minus 1/2 g times t squared. I could do that one. And then the other one is v squared is equal to v naught squared minus 2g times delta y. I'll probably choose the second one because it's a little less work for me. So what I'm going to do then is I'm going to say negative 27.44 meters per second squared is equal to 0 seconds or 0 meters per second squared minus 2 times 9.8 meters per second squared times delta y. Okay, so I'm going to plug all that in and solve for delta y, and that'll give me the distance or the height of the building. So in the next line I need 27. Whoops, gotta turn on my calculator. 27.44 squared. And I didn't put the negative sign, but you know when you square a negative it just becomes a positive. So I get 752.9536 and then that's meters squared over seconds squared minus, and then I'm going to say 2.8 times 9.8. We already know what that is. Whoops. 2.8 times 9.8. That's the 27 thing, right? Isn't that weird? Oh wait, but it's 9.8 squared, right? So let's do that again. So we're going to say second entry, and then I'm going to square this. I'm going to hit enters. And so all of this stuff is equal to negative 76.832 meters squared seconds squared. Actually, we're squaring the acceleration, so this is going to be seconds to the fourth, which is a little different. Delta y, okay? Okay, and so let me just double check everything, make sure that I'm plugging everything in correctly. And so now what I want to do is I want to divide by 76. So I get 752.9536 meters per second. But remember that when I divide this, we have to we're going to have to, you know what's troubling me? What's bugging me is that my units are not matching up. Okay? Oh, do you know why? I know why. Because the equation that I used, we had velocity squared and then acceleration. I don't know, let's finish it and see what it gets. All over 76, negative 76.832. Now this gets flip-flopped, right? So this would be seconds to the fourth over meters squared. But that's not a delta y. See the problem that I have? The problem that I have is that my units aren't matching up. Well, let's see if the numbers match up. Then we'll figure out the units. So I know by looking in the back of my textbook that the answer should be pretty close to 38. So I'm going to say 52.95 356 divided by negative 76.832. The only thing I can think of is that maybe when I squared my 27 squared, no, that's the right answer. So clearly I did something wrong there. Let's try to figure out what it is. I like to go through here because I know this is some of the problem that you guys, some of the issues that you guys run through when you do your homework at home. Let's look at this and try to figure out where Mr. Adams went wrong. We went through all this work and we got a final velocity of negative 27.44 meters per second. Okay, that's good. But then we tried to determine what the height of the building is, which is really delta y, right? We wanted to find the difference in the distance from the initial position to the final position. So I chose this equation. And when I look in the book, I think I chose it correctly, right? So when I take, so from this point here, I look at the equation, v squared equals v naught squared minus 2 times the acceleration due to gravity times delta y. Okay, so far so good. So when I square my 27, so if I take negative 27.44, okay, and I square that, I get the 752.96. Okay, that's good. That's good. So now this, it looks okay, and then when I square that I get meters squared, and then over here I'm going to get my seconds squared, so that looks good. So now to do this next part, oh, do you see what I did? I caught it right here. Mr. Adams looked up and saw GT squared, and I accidentally wrote down squared. So really, this is where I made my mistake. It's pretty common to make a simple mistake like that. This doesn't have to be squared. So what I really have is I have 752.9536 meters, okay, squared, seconds squared, and that is equal to negative 2 times 9.8. So if I say 9.8 times 2, it's really negative 19.6 meters per second times delta y. See, when I squared that, I accidentally squared the units, and that's why I didn't get meters. But now watch what happens. When I divide both sides by 19.6, remember I'm going to flip-flop these, so it becomes 752.9536 meters squared, seconds squared, because this goes on top, all over negative 19.6, and then this second squared stays on the bottom, but this meters comes down here, and that's all equal to delta y. So what happens is one of these meters cancels with one of these meters, leaving me with meters there. This cancels. And so now, if I take 752, and notice Mr. Adams entered in, I should have put this in parentheses, 752.9536 divided by 6 divided by 19.6, I've got 38, but it's a negative 38 because the displacement is in the negative direction. So negative 38.4 let's just round it to 38.4 meters. Negative 38.4 meters is my delta y. What does that mean? I'm going to have to recap that one so it makes sense. Well, what it means is that if I drop this ball and it hits the ground in 2.8 seconds, that means that if my initial position was 0 meters here, my final position was 38.4 meters further down, and so really that's the height of the building, right? It's 38.4 meters. And here we use unit analysis, and we used it incorrectly, and it was again the unit analysis that pointed out the error of Mr. Adams. I accidentally, because I wrote down two equations, kind of made up my own equation on the fly, which wasn't correct, which threw off my units, and that's how I caught my mathematical mistake. And I got the right answer. Any questions?